Hello, welcome everyone to another episode of the Virtual Ninja Show. My name is Heike, and today I have two guests with me, and I start with Kijo. Kijo, please introduce yourself.
Thanks, Heike. Hi, everyone. I'm Kijo Girardi. I'm a product manager working in a customer experience engineering team, especially looking at Microsoft Defender XDR.
Perfect. Thank you so much. And then Shaleen, also please introduce yourself.
Thank you so much, Heike. I'm Shaleen Dev. I'm a senior security researcher at Microsoft. I'm part of the identity threat detection and response team, focusing on non-human identity-based threats and especially applications, OAuth applications. And I'm also a frequent speaker at multiple international conferences like Cocoon, Cloud Identity Summit, MITRE, etc.
Wow, okay. I need to look this up. Thank you so much for sharing. Um, our topic today is OAuth applications in the context also of how attack disruption can help here. Before we actually get into that, Kijo, can you please educate us all? What are OAuth applications?
Okay, Heike. So first, OAuth is an open standard for token-based authentication and authorizations, which is the token itself allows the app to access the data without any password interaction. So that's the main feature of the OAuth application.
Which sounds super simple and easy, right? But so why are they risky?
OAuth application is really, really simple and quite useful in our business context. But at the same time, attacker leverage this OAuth application, for example, persistence purpose or defense evasion, because attacker, since they got the access to the application, based on the what's kind of the permission the OAuth application has, attacker can conduct a number of the attack technique. So that's why it's quite risky.
So, Kijo, we use them at Microsoft. So I get this little window where they ask for my permissions, read the profiles, read whatever. How do I know? I should say yes, consent. It's not someone lurking me into an OAuth application that I give them my access to. Is there any, how do I know? Because I think it's easy for attackers to, just send me a link, I click on it, and then I say yes.
Okay, so this is a really good question. So when you look at, for example, this application request, attacker sends the suspicious email. In the email, it could be included as something, the link to ask the app consent. So that's a great example. When you click the accept, this is exactly the attacker what they are trying to do. Because depending on the application consent, you will see a number of the lists. Like this app is trying to access like a read write group, or maybe send an email, or maybe add a role. Depending on what they write it down, once attacker, like for example, you click the accept, attacker is possible, for example, sends a suspicious email, also possible to add global administrator role, or even they can delete the email, access to the mailbox. That's why it's quite easily for attacker to conduct this attack. So also it's not better to click.
So I see in the screen here it says unverified. So I think people should be cautious and should really look into, first of all, where it's coming from. The first place it would be the email already. But then also what is all requested, right? So basically, okay, I purposely want to use this app and I know the app is doing this and this. So it might need the permissions to also access this and this. But all these things, like when I read this, I would never say, yes, sure, go for it. You can read my emails and send emails from my account. So I guess it's human sense that we also ask people to apply here. So I know like there's different ways how attackers can then also leverage or like use OAuth applications. What are some of the examples that you brought?
Okay, so let me talk about the some attack vector in OAuth applications. So in OAuth application, attacker usually going to get access to tenant and then create OAuth applications or get access to the OAuth application. There are three typical patterns. One is malicious OAuth applications. The second is compromised OAuth application. Lastly, dormant OAuth application. In the first one, malicious OAuth application, what the attacker is going to do is they're going to create their own application in attacker host and send the email. This is exactly what you're talking about, like consent application. The other one is attacker access to the victim tenant, then create OAuth application. So that's the first one about the malicious OAuth application.
So it is, Kijo, it is in general the OAuth application is from the attacker and it's seen as a malicious. It's not we are using a malicious OAuth application that the attacker can then take over or like hack into. It is the OAuth application itself is malicious coming from the attacker.
This is yes possible scenario. So attacker create their own OAuth application and then just send the consent. This is much simple because what the attacker has to do is just create the OAuth application their side and then send the link with the consent app. Then only the victim user click the consent app. Then attacker technically possible to conduct the attack. So that's why like attacker creates the application in attacker host side. So the second one is compromised OAuth applications. So literally it's compromise. That's why what the attacker is going to do is they're going to access to the victim tenant somehow dictionary attack or AITM, whatever, just initial access, they access to the tenant. And after, what they're going to do is they're going to target on the existing applications. Existing application, that way they're going to add additional permissions or they even create the secret to the existing application. That's why it's like attacker is going to compromise the existing OAuth application. That's the second one.
Wow, okay. And then I see dormant. There's an app that's sleeping for a while, not used. Also for everyone out there, watch your applications and make sure that they're inactive, disabled, not used, cannot be leveraged. But explain, please, Kijo, what the attacker is doing there.
This is exactly what you said. So dormant is definitely attacker is targeting on application which are not frequently used. So it's same as another scenario like identity, like they're going to target on non-used applications. That's why it's like why do we attacker is doing the same attack as other compromised OAuth application, malicious OAuth application, but this time like looking at specifically dormant. That's the last scenario.
So, and then, we talked a little bit about the consent and what the permissions are, but what do the attackers usually do then now with these, applications or when they have access to them?
Let me talk about what the OAuth application does after attacker really creates OAuth application, or even maybe they update the permissions. Here's an example that we have seen attack in Storm 1283. So what the attacker is going to do after creating application is they are going to, for example, deploy the virtual machine and the Azure platform. This is for a crypto mining purpose. Or we have seen a business email compromise scenario. Usually when we see a business email compromise is they're going to access to the tenant and then they're going to hijack the email, creating forwarding rule, or even they're going to conduct the internal phishing email. But this time, since the attacker creates or get access to the OAuth application, they're going to do everything these activity done by OAuth application. So that's the attacker is going to do usually in OAuth application.
It depends, right? The consent that you give and the user that are giving the consent. So be careful. So what other examples of recent attacks can you share?
Okay, so this is just the history how OAuth application has been evolving every single day. So the OAuth application in the beginning, we have observed 20 and 19. At the moment, we start looking at the consent phishing. Exactly, we talked about in the beginning. But after OAuth application, this attack has been evolving the spam email. After they create OAuth application, instead of conducting something malicious activity in the email, they are now switching to sending a spamming email. That's what they are doing. But today, 2023, even today, what we are looking at it is first cryptocurrency mining. That previous the slide we talked about it. They create a virtual machine and then they're going to use that virtual machine for the crypto mining or even spamming as well. But what we are also seeing that another activity is business email compromised. Usually business email compromise, they are going to access to the tenant and they are going to hijack the email thread or access to the mailbox or creating forwarding role. But this time, when we say business email compromise, they are going to highly leverage the OAuth application. So for the attacker, they don't access to the email actually. Instead, they use the everything OAuth app and using Graph API and the whole activity done by behind. So that's why for attacker easily can bypass like hiding the activity. So that's why this is like quite risky in a OAuth application.
So thank you, Kijo. Now I'm moving to Shaleen. Shaleen, you are from the research side of the house. How does such an OAuth application attack look like from a detection standpoint, and then also surfaced into the Microsoft Defender portal?
Thank you, Heket. Let's go get into a case study on how OAuth applications are leveraged specifically in a business email compromise scenario, and let's see how the threat actor progresses throughout the attack scene and how we as defenders, as part of Microsoft Defender, is detecting all these threat actor activities. So at the initial access phase, mostly we have seen threat actors leveraging either AITM, phishing URLs being shared across emails, or it is mostly password spray whenever customers, victims haven't enabled MFA. And post that, when a user clicks or if there is a successful password spray activity, we have always seen a suspicious anomalous IP address through which the threat actor has signed in using the compromised user. And this is where it gets interesting because the threat actor stays under the radar, leveraging OAuth application from the persistence phase till the lateral movement phase. So there will be no activity performed by the user who's compromised. This is exactly where we fail to detect, customers fail to kind of uncover the threat actor's activities. And at the persistence phase, the threat actor is seen registering an OAuth application either via Azure CLI or via the Azure portal, but mostly via CLI, and adding high permissions and secret to the particular OAuth application. So in most of the cases, what we have seen is Microsoft Graph API permissions being added. And this particular OAuth application is leveraged to perform certain discovery activities like listing out the users, groups associated, roles, particular app roles that are being there, if the MFA is enabled or MFA status, and then also performing certain business email compromise activities, which is specifically searching for users email boxes, looking for multiple emails and also associated users as well. And followed by the threat actor is seen performing Graph API calls to create forwarding rules in order to forward these emails that are being present in the compromised user to other user accounts or to multiple other users. And this is where the threat actor also proceeds further by escalating the privileges to a global administrator role of the or any other privilege roles. And the threat actor is finally seen performing kind of a internal phishing campaign by sending bulk emails across the same organization or to multiple other organizations which are associated. And as part of Defender, we kind of detect throughout the kill chain with multiple detections at place all the way from initial access to the lateral movement phase, wherein we have anomalous token or activity from Tor IP detections at the initial access phase, followed by suspicious OAuth app registration or malicious OAuth app application registered by a compromised user at the persistence phase, and few other detections as well. And also have detections from the discovery phase to lateral movement phase where we see Graph API activities being performed by the OAuth application. But the question that arises is, we do have detections and detections are good, but is that enough? And that's exactly where we wanted to proactively disrupt the threat actor when the actor is active, and at the stage when the threat actor leverages the OAuth application. And that's where, though we have detections in place, we are in need of disruption, and we have leveraged the latest disruption capability in XDR disruption to disrupt the threat actor just after the persistence phase, where the threat actor registers a suspicious OAuth application.
Question for me to understand. So, they create a new OAuth application and add privilege permissions and secrets. But in order to get now the user list, groups, roles, and so, like, is it now they send the app to other users so they open it, or what is being used with the app?
The app is given high permissions in a way that the app can perform admin level activities, like the whatever an admin can do, a user or admin in a particular tenant can do, can be performed with an OAuth application. That's why non-human identities are becoming more of a like greater threats than human identities.
Yeah. Okay, so I mean, as people know who are watching the Ninja Show, I'm a huge fan of attack disruption. Um, so I see it already disrupts by probably, I would say, blocking access of the OAuth application, or like, what do we block now?
Yeah. So at present, any new sign-ins to the service principal of the OAuth application will be disrupted. So the service principal would be an instance of a particular OAuth application in a particular tenant where it is consented to be used. So as you were asking, if the particular OAuth application is being consented in a different tenant, maybe another victim, it would have a different service principal, and we would have user sign-ins to that service principal disrupted at that time. So that's how it is.
Mhm. So let's have a look at, because I would assume, we talk about we have detections for all these. How do they look like in the portal? Like, I guess we will have a nice graph that shows us and their attack story, but what are the different alerts that are being raised?
This is how exactly an incident graph would look like. Typical incident graph when a business email compromise scenario happens. So we would see a sign in from a Tor IP address, as I mentioned, based on the case. So we might have a Tor IP address activity by the compromised user, followed by a suspicious OAuth application registration detection, and followed by, this is where it gets interesting, because the OAuth application gets active and leverages a graph API activity. So we would have alerts specifically for OAuth application performing certain graph API activities, and we also will have suspicious email forwarding rule detections being triggered as well when the app is performing certain activities which was suspicious. And then we would also see a global admin role being assigned to a particular user if the app is used to perform such activities. And also, when the app is leveraged to perform spam or phishing activities, we would have that detection also triggered. So this is how it would look in the incident graph.
Mhm. And where would attack disruption kick in now again?
For that, let's compare it with a typical scenario where the threat actor was successful enough, and then let's see how efficient we are at disrupting the threat actor. So this is how the timeline would look like. This is actually a real-time scenario that we have seen as well in a campaign where multiple apps were involved, and these apps were registered through across multiple tenants with the same pattern in the application metadata, maybe that application names and the reply URL, etc.
Why are they taking so long? Why are they taking so much time, like T plus 47 hours? Like, what did they do? Go to sleep?
This is exactly what they wanted as the thing, because it is expected always that the threat actor would make the application active immediately, but they don't. They actually wait, because most of the detections
Timestamps. And yeah.
timestamp based.
Mhm.
Yeah. So in this ideal scenario, what we had seen is the threat actor had sent a suspicious URL over an email, which was kind of clicked at T minutes here. and clicked just before that t minus 1 minute, and I've considered t minutes is where actually the user gets compromised, and the threat actor logs in with the compromised user with a high risky sign in. So after t minutes, at 1 minute after that, the user compromised user was used to create a malicious OAuth application. So the first category among the applications that Kijo had mentioned earlier, and later the threat actor had waited for almost 47 hours. It's close to 2 days, and then used the compromised user to create an inbox rule. In similar cases, what we have seen is there is always a suspicious name in the inbox rule names. So it was three dots, which is very suspicious. And this was followed by the threat actor again taking some time to again log in with the compromised user. The threat actor is waiting to see if there is any action being performed, and then performs further activities and moves forward. And then post an hour again, the threat actor updated the scopes. So until then, there was no permissions added. So the threat actor waited almost for 52 hours to add certain high scopes, which is mainly offline access of emails, user read permissions, permission to send emails, and read and write emails as well. So to modify the emails. So these were all high privileges that was added to the OAuth application, and still there was no action, and the threat actor waited for another hour, and the OAuth application was seen accessing 46 email folders just after that, and also had sent 3.5k around 3.5k phishing emails using Graph API. So this is how the OAuth application was leveraged for business email compromise and phishing.
Mm. I think it's so important to mention it, like, especially with like the time waiting, it's not the time only, right? There is so much logic behind our detection, and like the attacker is also somewhere else. Like, it's not on this device, same user. Yeah. And where is disruption now kicking in?
Yeah, that's exactly. So, what we had seen is this particular tenant, we had a disruption, but it was something like a SOC remediation action that had happened after 2 hours. 2 hours after the app got active and phishing emails were already sent. So it was more than 3.5k emails. So there was a admin action, and it was deleting the malicious OAuth application. This is an ideal scenario without our automated disruption action in place. But if we compare it with the Defender automated disruption action, this is where we disrupt. So as part of the same campaign, in another tenant, we had disrupted the user as well as the malicious OAuth application just after the user had clicked and then had a risky sign in. So we had disrupted the threat actor within a minute.
Wow. Pretty cool. So, and then basically step 5 towards didn't happen because we disrupted them. Okay.
That's all. So we have shifted left all the way at the persistence phase, as I was referring earlier, and we were successful. Now let us see how does it look in the portal. So this is how an ideal disrupted attack would look like when an OAuth app is involved, and we can actually hover over and then check for the action status in the action center. This is where the malicious OAuth application has been disrupted. We can actually check the app's disruption status here, and any sign-ins to the service principal of this particular OAuth application is disabled now.
So, this is great. Thank you so much, Shaleen. And I know we have a lot of people that also love to use advanced hunting to get a few more details out during their investigation. Can one of you share a couple of advanced hunting examples?
All right. Let me take a look first. Advanced hunting. We look at the attack disruption in the incident regarding the OAuth application, but also we want to know how to hunt the suspicious activity, especially OAuth application creation. Usually, we can just filter the cloud application activities. But of course, if we just only filter like update application, add application, etc., it could be quite legitimate. So that's why in this query, what we are doing is we have to do additional query. That means we have to look at how the app was created. So that's the part we want to highlight. So before I run the query, let me explain one by one. So we use the two different tables. One is the line 4, AAD sign event beta, and the second one is line 12, cloud app event. So first, let's take a look in AAD sign beta table. Since I said like we want to look at how app was created, so we have to look at the enter activities. So in these enter activities, we filter the time and also error code here. And also we have to take a look the risk level during sign in. So when we filter more than 50 means definitely suspicious sign in. So attacker could be using the anonymous IP address or using Tor IP or even others, the technique to hide their footprint. So that's why after we filter these activity in a sign in, and then we take the account object ID, which is usually account user account. Then after we can linked with the sign in activity with cloud at event. Then after we filter, definitely we can hunt some suspicious activity. The app was created with the account which somehow access to the Azure portal with suspicious IP address. So let's just run the query, and then let's take a look what kind of information it's returned. All right. So this is for example, the data we have been seeing. So as you can see, these data is definitely suspicious because the user created or deleted application. But the important point is it's not just we deleted the create application. The user somehow access to the Azure portal or Azure portal app registry place with a suspicious IP address. That's the key point that how we can track the suspicious activity, especially when attacker creates the OAuth applications.
So, Kijo, I know people love our queries that we already share with them. So, where can they find them?
People can access to threat analytics in the Defender XDR. Then they can just search the OAuth application. Then you can find the number of the great queries exactly like I just write it down here.
Okay, thank you so much, Kijo, and thank you so much, Shaleen, for walking us through this attack scenario of OAuth applications and explaining how our customers with Defender are protected with attack disruption, where we disrupt the attacker on the way to the ground jewels. I hope I will have you back to the show with maybe a new scenario. I know that we keep improving and enhancing. And for now, thanks everyone. Thanks for watching. Bye.